Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Epoxides, oxiranes, are three-membered cyclic ethers with significant ring strain. Nucleophiles can open epoxide rings via substitution mechanisms. Moving on to the next step. The substrate is an epoxide, oxirane, and the reagent is R2NH, a secondary amine acting as a nucleophile. Moving on to the next step. The nitrogen of R2NH acts as a nucleophile and attacks one of the carbons of the epoxide ring. The CO bond breaks as the nucleophile forms a bond with carbon. This is a bimolecular process. The nucleophile attacks in a single concerted step with inversion of configuration at the carbon center being attacked. And for the final step, because the reaction involves a nucleophile directly attacking the back side of the CO bond in a single step, concerted, with bond formation and bond breaking occurring simultaneously, this is characteristic of an SN2 mechanism. Epoxides are excellent substrates for SN2 reactions due to their ring strain, which provides thermodynamic driving force for ring opening, while the reaction still proceeds via a bimolecular transition state. SN1, SN1 requires formation of a stable carbocation intermediate. Simple unsubstituted epoxide, ethylene oxide shown, does not readily form a stable carbocation, so SN1 is not favored under neutral basic conditions with a nucleophile like R2NH. Electrophilic addition. See, the amine is a nucleophile, not an electrophile. The epoxide carbon acts as an electrophilic center, but the overall reaction type is nucleophilic substitution, not electrophilic addition. SNNGP, the neighboring group participation involves an internal nucleophile assisting in displacement. No such intramolecular neighboring group is present in this simple bimolecular reaction. Therefore, the correct answer is A. Therefore, the correct answer is option A.